In this lesson we're going to look at the concept of power. Now power is a measure of the rate at which energy is transformed by a device. For example, we can say that power is the measure of the rate at which work is done. So we can say that the power is the work done by the device, motor, engine, or whatever, divided by the time taken for that work to be done, or for that energy to be transformed. So we can write that as equal to W divided by T, and the unit for work is the joule. Work has the same unit as energy, so it's joule per second. Okay, and then along comes somebody and says, you know, I'm a very famous scientist and I'm going to name this compound unit after me, just to confuse hundreds of students, physics students in the future. And so the joule per second is replaced by the watt. Okay, there we go, or W. So we can say that the unit for power is the watt, but we must always remember that that is joules per second. It's the energy being transformed within a given time. So we can work out, for example, here the power rating of this Citroen 2CV, this small car. Let's say that it has a mass of about 600 kilograms. I believe that is about right for a 2CV. Alright, 600 kilograms, and we started up from rest. That means that its initial kinetic energy is 0, and then after say 10 seconds it's travelling at 20 meters per second. Alright, so during this period of acceleration we want to work out what was the output power of the motor. And so to do this, we remember that the work done by the engine is equal to the energy transferred, which is equal to the change in kinetic energy, all right, which is the final kinetic energy minus the initial kinetic energy, which was 0 since the car was at rest. So that's equal to the kinetic energy of the car. So at this point its kinetic energy is a half mv squared, which is equal to a half times 600 times 20 squared, which comes out as 120,000 joules. So again, the power of the engine was equal to the work done divided by the time taken, which is equal to 120,000 joules divided by 10, which was equal to 12,000 joules per second, or 12,000 watts, or 12 kilowatts. Likewise, we might have another situation. Here we've got a motor which is lifting a block of 40 kilograms up the side of a building, and we might want to find out what is the power output of this motor if it takes exactly a minute for the motor to lift the block to the height of the building. We would say that the power is the energy transferred, that's the work done, divided by the time taken. That's to say it's the energy transferred, and the type of energy that's being transferred here is gravitational potential energy. So its initial GPE is 0, its final GPE is equal to the mass of the block times G, the gravitational field strength, which is normally taken as 10 times h, which is the height of the building, let's make a note of that, divided by t. So that comes out as m, which is 40, times g, which is 10, times h, which is, let's say, 20 meters, times 20, divided by 60 seconds, which gives us 133.3 watts, or joules per second. Okay, so that tells us the power output of the motor.